According to Underwriters Laboratories Standard 2024 and National Electrical Code Section 725.71H, voltage ratings are not required on Plenum rated cables. This is because the voltage rating is embossed on the cable's inner jacket, which is not visible when installed. Regarding the use of Class 3 cable in starters, National Electrical Code Section 725.55 subsections B through J do allow the use of Class 3 cable for wiring within motor starters, provided that several conditions are met. Firstly, the cable must be protected from physical damage. Secondly, the cable must not be subject to excessive heat or vibration. Thirdly, the cable must be terminated in a manner that ensures good electrical connections. Fourthly, the cable is not used outside the starter enclosure. The interpretation of National Electrical Code Section 725.55 subsections B through J is that Class 3 cable can be used for wiring within motor starters, provided that the specified conditions are met. It's important to note that the cable should not be exposed to the same stringent conditions, such as excessive heat or vibration, as typical Class 3 wiring. It's not uncommon for inspectors to be unfamiliar with the requirements for low-voltage wiring, including Plenum cable and Class 3 cable. Therefore, it's important to provide the inspector with documentation, such as Underwriters Laboratories listings and relevant code sections, that supports the interpretation. When working with low-voltage systems and Class 3 wiring, several crucial considerations need to be taken into account to ensure safety and compliance with electrical codes. These considerations span from selecting the right type of cable and understanding its voltage ratings to properly installing and protecting the wiring system. A detailed examination of these aspects is essential for anyone involved in the design, installation, or inspection of low-voltage Class 3 systems. Firstly, cable selection plays a vital role in the overall performance and safety of the low-voltage system. Class 3 cables are specifically designed for low-voltage power and control circuits, where the voltage does not exceed 150 volts direct current or 300 volts alternating current. When choosing a Class 3 cable, it's important to consider the specific application and environmental conditions to which the cable will be exposed. Factors such as temperature, moisture, chemical exposure, and physical stress can all impact the cable's performance and longevity. Secondly, voltage rating is a critical parameter that indicates the maximum voltage a cable can safely handle. While National Electrical Code Section 725.71H states that voltage ratings are not required on Plenum-rated cables, it's important to verify that the cable's inner jacket does indeed have the appropriate voltage rating embossed on it. This rating should be sufficient for the intended application and comply with the relevant electrical codes. Overlooking this detail can lead to insulation breakdown, short circuits, and even fire hazards. Thirdly, proper installation techniques are essential for ensuring the reliable and safe operation of low-voltage Class 3 systems. The National Electrical Code provides detailed guidelines on how to install cables, including requirements for support, spacing, and protection from physical damage. It's important to follow these guidelines carefully to prevent cable damage and ensure that the wiring system is properly secured. In addition, care should be taken to avoid kinking or bending the cable excessively, as this can weaken the insulation and compromise its integrity. Fourthly, protection from physical damage is a crucial aspect of cable management. Class 3 cables should be routed in a manner that minimizes the risk of abrasion, impact, or other forms of physical damage. This may involve using conduit, cable trays, or other protective measures to shield the cable from potential hazards. In areas where the cable is exposed to heavy traffic or machinery, additional protection may be required to prevent accidental damage. Fifthly, termination methods play a significant role in the overall performance and reliability of low-voltage Class 3 systems. Proper termination ensures a secure and low-resistance connection between the cable and the connected equipment. It's important to use the appropriate connectors and tools for the type of cable being used and to follow the manufacturer's instructions carefully. Loose or improperly installed connections can lead to voltage drops, overheating, and even electrical failures. Sixthly, grounding and bonding are essential for maintaining a safe and reliable low-voltage system. Grounding provides a path for fault currents to flow back to the source, tripping the circuit breaker and preventing electrical shock hazards. Bonding ensures that all metal parts of the system are at the same electrical potential, reducing the risk of stray currents and electrical noise. The National Electrical Code specifies the requirements for grounding and bonding low-voltage systems, and it's important to follow these guidelines carefully. Seventhly, compliance with National Electrical Code Section 725.55 subsections B through J is essential when using Class 3 cable for wiring within motor starters. These sections outline specific requirements for the installation and protection of Class 3 cables in motor control circuits. It's important to understand these requirements and to ensure that the installation complies with all applicable codes and standards. Failure to do so can result in code violations, safety hazards, and potential liability issues. Eighthly, documentation is a crucial aspect of any electrical installation, including low-voltage Class 3 systems. Accurate and up-to-date documentation provides a record of the installation, including cable types, voltage ratings, installation methods, and grounding and bonding details. This documentation can be invaluable for troubleshooting, maintenance, and future modifications to the system. It's also important to provide documentation to the electrical inspector to demonstrate compliance with applicable codes and standards. Ninthly, regular inspection and maintenance are essential for ensuring the ongoing safety and reliability of low-voltage Class 3 systems. Inspections should be performed periodically to check for signs of cable damage, loose connections, and other potential problems. Maintenance should include tightening connections, replacing damaged cables, and verifying the integrity of the grounding and bonding system. By performing regular inspections and maintenance, potential problems can be identified and corrected before they lead to safety hazards or system failures. Tenthly, ongoing training and education are essential for anyone involved in the design, installation, or inspection of low-voltage Class 3 systems. Electrical codes and standards are constantly evolving, and it's important to stay up to date on the latest requirements. Training courses and seminars can provide valuable information on cable selection, installation methods, grounding and bonding, and other important topics. By investing in ongoing training and education, electrical professionals can ensure that they have the knowledge and skills necessary to design, install, and maintain safe and reliable low-voltage systems. Understanding the nuances of Class 3 cable usage within motor starters, as delineated in National Electrical Code Section 725.55 subsections B through J, requires careful attention to specific conditions. These conditions are designed to ensure the safe and effective operation of the electrical system while mitigating potential risks. A detailed breakdown of these conditions is crucial for proper installation and compliance. First condition stipulates that the cable must be protected from physical damage. This is paramount to maintaining the integrity of the cable's insulation and conductors. Physical damage can result from a variety of sources, including abrasion, impact, and compression. To mitigate these risks, the cable should be installed in a protective conduit or raceway, particularly in areas where it is exposed to potential hazards. The choice of conduit material should be appropriate for the environment, considering factors such as moisture, chemicals, and temperature. The second condition emphasizes that the cable must not be subjected to excessive heat or vibration. Excessive heat can degrade the cable's insulation, leading to premature failure and potential fire hazards. Similarly, excessive vibration can cause the conductors to fatigue and break, resulting in intermittent or complete loss of signal. To avoid these issues, the cable should be routed away from heat sources and secured in a manner that minimizes vibration. Vibration dampening materials can be used to further reduce the impact of vibration on the cable. The third condition mandates that the cable be terminated in a manner that ensures good electrical connections. This is critical for maintaining a low resistance path for current flow. Poorly terminated connections can result in voltage drops, increased heat generation, and even arcing, which can lead to electrical fires. To ensure good electrical connections, the cable should be terminated using appropriate connectors and tools. The connector should be properly sized for the cable's conductors and installed according to the manufacturer's instructions. The terminations should be inspected regularly to ensure that they remain tight and corrosion-free. The fourth condition specifies that the cable should not be used outside the starter enclosure. This is because the starter enclosure is designed to provide a controlled environment that protects the cable from environmental factors such as moisture, dust, and chemicals. Using the cable outside the enclosure would expose it to these elements, potentially leading to premature failure. If it is necessary to run the cable outside the enclosure, it should be installed in a suitable conduit or raceway that provides adequate protection. Addressing the potential for confusion among inspectors regarding low-voltage wiring requirements necessitates a proactive approach to ensure clear communication and understanding. This involves providing comprehensive documentation, highlighting relevant code sections, and being prepared to address any questions or concerns the inspector may have. A well-informed inspector is more likely to approve the installation, minimizing delays and ensuring compliance. Providing documentation is a critical step in clarifying any potential confusion. This documentation should include underwriters' laboratories listings for the cable, as well as relevant sections of the National Electrical Code that support the installation practices. The underwriters' laboratories listing provides assurance that the cable has been tested and certified to meet specific safety standards. The National Electrical Code sections provide the regulatory framework for the installation, outlining the requirements for cable type, voltage rating, installation methods, and protection. Highlighting relevant code sections is essential for demonstrating compliance with the applicable regulations. This involves identifying the specific sections of the National Electrical Code that pertain to the installation and providing a clear explanation of how the installation meets those requirements. For example, if the installation involves the use of Class 3 cable within a motor starter, National Electrical Code Section 725.55 subsections B through J should be highlighted. This section outlines the conditions under which Class 3 cable can be used in motor starters, including requirements for physical protection, heat resistance, and termination methods. Being prepared to address any questions or concerns the inspector may have is crucial for resolving any potential issues quickly and efficiently. This involves having a thorough understanding of the installation and the applicable codes and standards. It also involves being able to explain the reasoning behind the installation practices and to provide supporting documentation as needed. If the inspector raises concerns about the installation, it is important to listen carefully and to address those concerns in a respectful and professional manner. Providing additional information or making minor adjustments to the installation may be necessary to satisfy the inspector's concerns and to ensure compliance with the code.